So imagine that one of your friends says, "Do you fancy popping around tomorrow afternoon? I've got a few friends coming over. I'm sure you'll get on well with them." And you say, "Yeah, I don't mind. How old are they?" And they say, "Well, the average age is 17." So I say, "Well, okay, yeah, good. I'll come." And then when you get there, the ages of the people there are 1, 1, 1, 4, 4, 4, and 103. You say, "You said the average age was 17." And you say, "Well, it is. If you add up those numbers, the total of those numbers is 119. So the mean is 119 over 7, which is 17. You say, "Well, you should have told us something about that data. Should have told us some measure of spread. I didn't realise it was going to be loads of babies and one very old person. I'm sure they're all lovely people, but I don't really want to spend time with loads of babies and a very old person. Thank you." So a measure of spread would be a good idea. And at GCSE, you look at the range. It's the biggest number minus the smallest number, and the range is 102. So if you'd said the average age or the mean age is 17 and the range is 102, that would have given you more of an idea about the people going to your friend's house. So next week the same thing happens. You fancy popping over tomorrow afternoon, and you say, "Yeah, you caught me before, I'm not falling for this again. What's the average age? 17. And what's the range? 67. Well, it's going to be the same." You say, no, there'll be some people there your age, because the people there, yeah, there are some little kids there, but there's going to be 3 16-year-olds and a rather groovy 68-year-old person. And the total of those numbers is 119, and 119 divided by 7 is 17. So the range is 67, but the range is a little bit misleading, because all the range does is look at the smallest number and the biggest number and find the difference between them. What we're looking at in this video is a measure of spread that takes account of every single number, and this measure of spread is called the standard deviation. So let's take those numbers again. We've got 1, 1, 1, 16, 16, 16 and 68, and we know that the mean is 17. So firstly we're going to work out the deviation of each of those numbers from 17. So 1 from 17, that's 16 below. There's 3 that are 16 below, 3 that are 1 below, and there's 1 that's 51 above it. Now if I find the total deviation of those numbers, the total deviation is 0. The fact that the 1 is 16 below the mean and the 68 is 51 above the mean, the minus signs really aren't that important. So what would be a good idea would be to square these numbers. So I'm going to square the deviations, and that will get rid of the minus signs. So that's 2, 5, 6, 3 of those. 1 squared is 1, and 51 squared is 2601. So now let's add those numbers up. Let's add up 256, 256, 256, 11 and 2601, and that makes 3372. Oops, there we go. Total 3372. Now we had 7 numbers, so the mean of these numbers is 3372 divided by 7, and because we squared before, we should take the square root to get it back to the right dimensions, and that number works out to be 21.9. So the standard deviation of these numbers is 21.9. So let's think of a better way of setting this out. Let's go back to the first example, where we had 1, 1, 1, 4, 4, 4, 103. When we add up the numbers, and that's the notation, sigma x, that's 119. So the mean is the sum of those numbers divided by 7, which is 17. So let's now do a column rather, showing the deviation from the mean. 1 is 16 below the mean. That's 16 below the mean. 4 is 13 below the mean. And 103 is 86 above the mean. So now let's square to get rid of those minus signs. So that's 256. That's 169. And 86 squared is 7396. So now let's add up all those d squareds and divide by n. So if you add up these numbers here, these numbers remember added up to 119, we add up the d squared numbers, it makes 8671. So it's 8671 divided by 7, which is 1238.7. So the standard deviation is the square root of that, 35.2. Now that's a bigger number than the one we had before. In the previous example we had the standard deviation to be 21.9, now we've got the standard deviation to be 35.2. It's measuring the spread. These numbers are further apart from each other than the previous ones. Right, so now we're going to write this as a formula. So the standard deviation is this. What did we get? We found each number. We found the difference between that number and the mean. We squared to get rid of minus signs. We then added the numbers up, divided by the total number of numbers, and then took the square root of the answer. And that's one of the formulas for the standard deviation. Now there's another formula for the standard deviation which I'm not going to prove now, we'll look at in class, and what that is finding each number, squaring it, adding up all those numbers squared, divide by the total number of numbers, and then take away the mean squared, and then take the square root of the answer. And in class we'll look to see why those formulas are identical. Finally, the symbol that's used for standard deviation is the lowercase Greek letters sigma, and there's another measure that we can use, which is the variance, and that is simply the standard deviation squared. In other words, it's these formulas without the square root sign. We'll be looking at variance and standard deviation later on in the course.